Hi, my name's Damien Edwards. I'm a program manager on the ASP.NET team. The first version of ASP.NET SignalR was released earlier this year, and with it, ASP.NET developers have been adding amazing real-time web functionality to their applications. In this video, we'll take a look at some of the improvements in the new version of SignalR that's included with Visual Studio 2013.
So the first thing to know about SignalR 2 is that we've fixed over 50 bugs from the first release relating to performance, stability, and API usage, which is great if you're looking to upgrade to the new version. Let's have a look at some of those API improvements that we've made that hopefully you can use every day in your SignalR applications. I have a demo hub here. It derives from hub just like we did in SignalR 1. And I'm just going to take a quick look here at the connected method that I've overridden so that I can run code whenever a new SignalR connection comes into the server. In this case, I'm just going to check to see if the user that's associated with that connection is authenticated, and if they are, I'm going to add them to a group called authenticated, and if they're not, I'm going to add them to a group called anonymous, and we'll see why in just a minute I've done that. So now, one of the first features that we've added is the ability to send the same message or invoke the same method on multiple clients at the same time using groups or client IDs. So you can see in this method here, it's a public void. It's going to be called from my client-side code, and it's taking in a string array which represents the names of the groups I want to do this invocation on. Now I have a new groups method I can call on clients and pass in an iList of strings to represent those group names. I can go ahead and call that method directly on multiple clients as long as they're in those groups. Now previously in SignalR 1, I would have had to have used the clients.group member and loop over this string array and invoke the same method essentially multiple times, one time for each group. What we have now is more efficient because we're only doing the serialization and the masking and creation of parameters the one time on this method, then sending that out to all the clients in one go. We can see that in effect. So I have Chrome running on the left-hand side here, and I have IE running on the right-hand side here. And ahead of time, I've gone ahead and authenticated the Chrome application. So you can see this one's logged in as a user called Chrome. And in Internet Explorer, I haven't logged in at all. So one of these is anonymous, and one of them is authenticated. I'm going to go ahead and click Send to Groups over here. You can see I have authenticated, anonymous in that text box. And sure enough, I've got in the console of both browsers a message saying that a method on the client was called from the server. If I go ahead and delete the anonymous group name now from the right-hand side and click that again, you'll note that all that happened was the count indicator in Chrome went up that time to indicate that it got that message again. If I do the same thing in Chrome but delete the authenticated group name and hit Send to Groups, as you'd expect, you can see that the message was only sent to the anonymous group this time, and so IE got the message instead. So that's a nice improvement that saves you having to for each over lists of groups or lists of connection IDs when you want to basically send the same thing to a bunch of people. We also have the ability now to send messages directly to users. Now in SignalR 1, the recommended guidance was you would handle on connected, get the connection ID and the username from the user and store that away somewhere in your application. While that's still necessary for certain types of functions in a real-time application, if all you want to do is send a message to somebody based on their username, we now have a first-class API for that. So you can see here clients.user, which is the new API I'm talking about. We can pass in a string username and then go ahead and invoke a method on those clients who have a username that matches that. So I've gone ahead and implemented that as well. So again, the left-hand side here is logged in as a user called Chrome, and the right-hand side is not logged in. So I'm going to type in Chrome into this box here and click Send to User. And over on the left here, you'll see Hello Chrome from SignalR 2. Now, because the IE browser isn't logged in as a user, I'm not able to send directly to that user, obviously. But this is another nice, handy API improvement that we've made that just removes some of the code that you would have needed in a SignalR version 1 application. We do that for you under the covers now. One of the other areas of improvement that we really focused on was around error handling. Now, in SignalR, by default, if you throw an error inside a hub invocation, those errors don't make their way back to the client. You'll get a generic error in the client saying, hey, something went wrong when I tried to invoke this server method, but you won't get any other details. And that's a security measure. It's best practice not to leak information about errors that occurred on the server back to the client. But obviously there are cases when you do want to return an error back to the client with useful information that your client code can use to give a better user experience. So we've made that a first-class experience in SignalR 2. We have a new exception type called hub exception, and I can go ahead and throw that, providing a nice user message that'll get flowed back to the client, and then any other arbitrary data that I think is useful in describing this error to the client. And of course, I have client-side code that deals with this as well. So let's have a look at my client-side code now. Again, looks very typical for a SignalR application. Let me scroll down to where I'm invoking this method called causeError. Now, if I flip back to the server code, you'll note that the condition here was that if A is less than 0, I'm going to throw one of these hub exceptions, which is the new type. And if it's greater than 0, I'm going to throw a standard invalid operation exception, which I wouldn't expect to be seen in the client. So currently I'm calling it with -1, and I'm going to show that error message on the screen. So let's go back to our clients. Let me just maximize one of these clients now so we can see what's going on. I'm going to call causeError. And so indeed, I've got that error being shown to the screen because I've written code to do so. Let me flip open the debugger. We'll come down to where this code happens. And we'll put a breakpoint here so we can actually see what's going on. So let's hit that again. So here's my error. And over in the watch window, we can see that my error is indeed an object this time, which has a message which came from the server, so that's automatically been flowed to the client for us. And we can see that the source was hub exception. This source is a new property in SignalR 2 in our JavaScript client that makes it easier to understand why errors have occurred when they occur in your application. So there are other errors that can take place obviously in SignalR as well. Perhaps the connection gets interrupted. So let me scroll up a little bit here. I've got another error handler here that's hooked up directly to the connection itself. So this will get fired whenever some type of underlying error happens to the connection. So let's force that. I'm going to go and stop my web server right now. Stop the website. And we can see that that's now triggered an error. If I look over my watch window again, previously in SignalR 1, this error would have simply been a string. And if you wanted to perform any type of conditional operation based on the type of error, you were really left to string parsing and kind of figuring out what was going on. Well, this time now we have a nice error object with a message telling me that the WebSocket was closed. I have that source property which gives me the actual root of what caused the error. Now, in this case, it was the close event coming from the underlying WebSocket API. And if the error was caused by a transport, then we'll have an extra property called transport, which actually tells me what transport caused the error. So again, much more useful information available to your clients about what caused the error so you can give a better user experience under error conditions in your applications. Lastly, we made a couple of other changes. First of all, we made a few of the types in hubs easier to mock. So if you want to unit test your hubs now, back on the server side here, that's going to be easier for you to do now. Things to do with the group manager and invoking methods on the client are now much easier for you to unit test. And lastly, we took a tighter dependency on OWIN. That's the Open Web Interfaces for .NET. I've opened up my startup class here, which is new in SignalR 2, and also shared with a lot of the templates that are in the other ASP.NET frameworks that have been released along with SignalR 2. And so now I have a startup class. You can see I'm calling a configure auth to set up authorization for my application. And then here you'll see the familiar sort of map SignalR call, which was previously called map hubs. The advantage of this startup class is that it's not tied directly to ASP.NET. So if I want to host my SignalR hubs and connections in a different process that is not on IIS, on a custom server, commonly known as self-hosting, I can do that now. This code doesn't have to change. All I need to do is bring in one of the supported packages to give me an alternate host, and I can run the SignalR portion of my app on a separate host. And indeed, if I look at my NuGet packages now, we even have a SignalR self-host package now. Let me search for that. And so now we have first-class support. Here it is for setting up SignalR self-host in your application using a listener such as the HTTP listener inside of .NET.
So we saw how ASP.NET SignalR 2 makes it easier than ever to add real-time web functionality to your applications. We've improved APIs for common tasks, better error handling, and easier unit testing for your hubs, and now official support for self-hosting on your own server via OWIN.